Let's see. All right, can you guys hear me all right? No, I spilled juice all over my DOS keyboard. I have I got another one to replace it. Is it noisy at all? I think I can do this. All right. All right, so I'm going to test the lag on here from IRC chat to Hangouts. Last time there was like a 30-second delay or something. So when I say, well, let me start a timer. Let me start a timer over here. All right. I'm going to start a timer. And when I hit this, when I say go, or yeah, when I say go, I want you to just like type the number 1 on your keyboard and hit enter when I say go. So I'm going to start the timer and see how long the lag is till you actually see what I'm saying. So go. All right, so the lag is about 45 seconds. That's pretty decent amount, but we can work with that. We worked with it last time. All right, how much minutes do we have left till 6 o'clock? All right, we got about 5 minutes. All right, let me check with the community over here. Make sure we share the Hangout link. Yes, I'm in the future. Sorry, guys. Tic Tacs. They're delicious. Storj, have we posted this on Reddit yet? Upvote. There's our link on Reddit. I'll probably answer a question or two from there. So mostly going to be pulling questions from the IRC chat. And then if we have some extra time, I'll look what's going on in that thread and answer some questions. So how's everybody doing today? Let's wait till we got 3 minutes. Let's wait till everyone like the time starts, so everyone can get here. And so let's wait a little bit before we answer like the really awesome questions. Let's see how everyone's doing today. Everyone doing all right? Having a good Sunday? Happy with the Bitcoin price? Wait. Get rid of the background noise. Sleepy? Let's see, what price are we at right now? Ew, 387.27 cents. Eh, stable, right? Not perfect, but stable. These Tic Tacs are delicious, man. Gotta decentralize the Tic Tacs. What are you calling? Okay, I can answer that. When will BTC moon? Good question. 2 weeks TM is the answer. All right. About 6 o'clock, so about time to get started. Okay, I think it's time. All right, so let's get started. My name is Sean Wilkinson. I'm the lead developer of the Storj project. And today we're just going to go over community questions. We'll go over some of the development we've been working on Metadisk and DriveShare, and just kind of keep it open. So whatever the community kind of wants us to ask us about, we'll answer. So we're live in Storj, Storj, on Freenode. And so that's where we're going to be taking a majority of our questions from. And then we also have a Reddit topic out there as well that we'll grab some questions from maybe towards the end. So trying to keep it to about an hour. Last time we did it was really long. So keep this about an hour. Again, just answer the questions that people have. So let's go ahead and get started. You guys are happy to start asking questions in IRC, and I will essentially answer it from there. So while I'm waiting for those questions to filter in, because there is a bit of a lag, I wanted to update you guys on the progress of our two software platforms. So Metadisk, we had one of our core devs, Josh, do essentially a full front-end rewrite for Metadisk. So before, it was kind of slow. Worked all right, but it was kind of slow. So now we have multi-file uploading, a lot more responsive interface. We have notifications, desktop notifications, and a whole bunch of other great features that he's built into there. So the next steps for Metadisk are to clean up the interface a little bit for the new design, and then change our backend a bit. We were having troubles with DataCoin that we're using for prototyping. So we're essentially looking at Foreign Coin for some of their metadata storage portions that they have added to it. So we're kind of looking at that as maybe a next step, but we're not sure yet. So that's making quite a bit of progress, and so we hope to have a solid something we can show for Metadisk in the next few weeks. Update for DriveShare, and I'll get more into this as people ask me questions, is thanks to one of our devs, William, we have an early farming prototype software demo that's in there in the GitHub repository. So we're cleaning that up. And essentially what we're working on now is some dashboard software. So we want to be able to give that to the crowd sale participants and early farmers. And essentially you want to get like good statistics on usage and whatnot. So that's essentially what we're working on right now. All right, so I think I heard a scratch at the door. Hold on. Come on. Ah, there's my little dog here. I'm at home. He's scratching on the door, so he'll join us for a few minutes for the Hangout chat. His name is Miko. Alright, so Pip says, can you give me a simple answer so I can explain this to others? What is the lowest amount of people that can be on the network and you'll still be able to retrieve your files? So essentially, when you have your file, you put your file on the network, it's broken up into a bunch of pieces. And so we basically use erasure coding for that. And so you might have a 1 gigabyte file and it's split up to 100 pieces. And then those files are distributed amongst the network. So you'll have nodes that will go down periodically for any which reason. And so we only need to have one of those pieces of those redundant copies essentially spread out on the network. And it really depends on the redundancy scheme you use, erasure coding scheme you use. So we recommend about 3 copies of that file need to be spread amongst the network or that particular chunk of file. So if anything goes down, it can easily recover. So you only have to have one copy on the network, but you don't want to just have that one copy on the network, because if that goes down, then you're in trouble. Okay, let's see. Yes, let's see. S-Jock next, and then I'll do Viva La. I can't see the rest of that. So yes, I went to a bunch of events last week. I started with Coins in the Kingdom, spoke there. Then I went, that was in Orlando. That was Jason King's event. Great event. And then I flew to Vegas, where I did Coin Agenda and spoke there. And then after that, I caught the end of Inside Bitcoins. And then after that, we went to Hashers United. So quite a big tour. I got a lot of people interested in storage. So I think that was an overall good trip to just educate people about storage. So yes, we've been around the last few conferences. The main things that we're gonna try to do some hard pushes are on the January, the Miami Bitcoin conference, and then I think we want to do CES, and then in March the Texas Bitcoin conference, where we'll be returning. So last year we participated in their hackathon and won first place unanimously. So we'll be returning as essentially a platform that's launched. So that was our first public presentation. It was at the Texas Bitcoin conference. So it'd be awesome to essentially return there. So let's see. So Viva La, I can't see the rest of his username. How do you plan to deal with civil attacks like those mentioned as MaidSafe's vulnerabilities? So it's really it's a twofold process. So one, the difference between MaidSafe, which is another peer-to-peer decentralized storage network, great guys. Essentially, hold on. Dog wants to leave. Essentially, the difference between our two networks is that they're building out this really cool peer-to-peer software to be able to keep track of files and essentially make sure they're there and they're redundant and available. We essentially have 2 options. So one, you, the user yourself, can verify that the files are still there and their integrity is solid. Or you can outsource that essentially to the network to do so. Now, the thing is that you can have multiple different independent auditors on the network. So you can be auditing yourself when you're online, and then you can have 3, 5 different auditors, whether they be groups of people or a single person, essentially auditing your files. So the thing is that you only have to have one honest person that are doing those verifications to say, hey, something's wrong, they're not holding the file, they deleted it, they modified it in some way. You only have to have one honest person, because anyone in the network can do these verifications, either yourself on your behalf. So that's a little bit different from MadeSafe in terms of building. They build, software and a network to manage this. We essentially just have auditing, and so that starts to essentially, that just crushes simple attacks for one portion, because you only have to have one honest node to be able to audit the files. And I find that's just a better way to do it. We want to essentially not give away all of our control in terms of checking that file and auditing. We want the user to have that control, and that solves a lot of the civil problems. All right, so let's see. What's the next question here? All right, so question, what are your thoughts on conversion encryption for deduplication? So yes, that's actually something that we implement now in Metadisk, and we plan to implement it as well as in Storj. So there's two parts of that. One is, if you have a public file like a cat picture, then you can essentially use conversion encryption, and you can place it out throughout the network, and it's pretty secure. But if someone else has that file, they also essentially get the same result. So it's fine for a public file like a cat picture, and so you get good deduplication on the network, and it's pretty secure from outside observers. Now, what you don't want to get into is you have some kind of private file or whatnot, and they want to prove that you uploaded this file, you have access to this file, and they have the files themselves, so they can use conversion encryption, essentially get the same file and say, aha, you had this file, you had access to this file. So we recommend conversion encryption for public files. We do not, we use separate schemes for private files. All right, let's keep on going down here. All right, so what happens if the auditors disagree? Is auditing designed in a web of trust band? So a lot of that is either decided by the user themselves or the application that they're running. So in the Storj network, we don't want to particularly lock the mechanisms, the encryption, the auditing mechanisms, the transfer mechanisms down to like one specific thing. We simply want to provide a set of tool sets and a set of modules to be able to do certain things like auditing and transferring and rewarding bandwidth and download. But we don't really want to get into the specifics of this is the way you should do it, because an application might come along that might need to do it differently, or we found a better algorithm, so we want to be able to swap it out. So we don't want to really get into this is the way it's supposed to be. So you can have mechanisms where you say majority of these nodes are honest, so I'm going to listen to the majority of nodes that are auditing this. I could say, I know this guy, I trust this particular node, or this particular auditing node is run by myself, and so I'm always going to default to that if something's wrong. And so you can start to build essentially many different mechanisms for this disagreement. And that's up to the application or the user themselves to decide what should be that policy if that happens. Let's see. So using conversion encryption, how does proof of storage work? Does it not require unique encryption? So essentially it depends on, so we have implementations on Metadisk that use conversion encryption. And essentially we haven't enabled proofs on there. But essentially it's the same thing. You can still do the proof of storage mechanisms on convergently encrypted files. What you have you start up having, if it's a popular file, you have essentially collision. So you have catpicture.jpg that you're hosting and you're distributing throughout the network. And then you have someone else who has catpicture.jpg and they're distributing it out throughout the network, and you're each doing a redundancy of, let's say, 3 or so. So you might be able to essentially skimp on some of your redundancy and some of your costs because someone is actually hosting the same file and verifying the same file. There's a lot of different mechanisms that you can essentially use when you're using conversion encryption with popular files. So like I said, there's not one particular method that we want to focus on. We just want to be able to put those methods out there and let the user of the application choose. All right, let's see. Yeah, so some of our community members are in here. They'll also be available to answer questions and whatnot if I miss anything. Let's check the Reddit talklet. Let's see if we have anything on there. Nope. No more questions. Awesome. All right, do we have any more questions that I missed? Let me scroll back up here. So yes, we have a tip bot somewhere up here. Let's see if it's... Okay, yeah. So I want to encourage the community members to show people how to use that tip bot there in IRC. We did a bounty for that a while ago, and so it's been working out for those of us who hang around Storj IRC chat. So let's test that out and start giving out some Storj coin to some of the users. All right, so Diva said, so what I'm getting from your answers is that most of the mechanisms on the network are controlled by the application user. If so, what does Storj handle that the applications don't? So yeah, so essentially we want the users to essentially have control of their files and their applications, because you might have a particular network that's having all kinds of trouble. I mean, we've seen the coins out there, and they're put out there. They work great for a little bit, but they have all these Sybil attacks. Well, not necessarily Sybil attacks and coin sense, but they have essentially 51% attacks and mining pools and all these other portions that lead to network instability and all of these things. Now the problem is, if you do that in a file storage network like Storj, instead of just essentially having a fork or having some network instability, start losing files. And that's not really fun, is it? You have your super important document up there, and you have some kind of network instability, and it gets wiped out. I don't think people would be very happy with that at all. So essentially, we remove that power from the network and give it to the users. And so it doesn't matter what's going on in the particular network, what's happening. The users essentially have the ability to do the auditing, do the transfer, whatnot, person to person. So it doesn't matter what's happening on the network or whatnot, I'm still able to connect with that peer over there and make sure the file is good and essentially pay that portion, that person providing me that service. And so it starts to, you have to think of, instead of mining, it's farming. It's more, I'm taking a resource and I'm selling it directly to the person on the other side. There is no brute force computation thing, finding a hash and then hoping you find the block and relaying it through the network. No, I'm using the storage network to find someone on the other side of wherever in the world they are to take my bits of file and then use the network to do those checks and do that payment. But it's more person to person than person to network. So it eliminates a lot of problems in terms of Sybil attacks and all these other portions that show up when you're trying to do these distributed networks. So let's see, I heard, what's the difference between Metadisk and drive share? Let's see, who asked that? Yeah, okay. So the difference between, so Metadisk is this file storage application that we currently have running as a web application. And so the whole idea is there is that you can drag and drop your files, and they can essentially encrypts it, splits it up into pieces, and distributes it out through the storage network. So it's a nice little front-end interface that you don't have to worry about all the technical specifics on how it works and whatnot. It's a simple drag and drop. So if you guys haven't taken a look at it now, I'm going to enter in the URL for you guys to try it out. It's node1, node, actual number 1.metadisk.org. And so you can try it out, throw a file or two in there, and download it back. So that's our first application. We're working on polishing that up so it can be used in production. The other side of that is the actual physical storing of the files on the network or on other people's hard drive. So that's what DriveShare is for. It's a simple application that you download, you click a button, and you're downloading chunks of files, encrypted chunks of files to your computer and getting paid in storage coin for that. And so that's kind of the other side of it. So think of them as two pieces of the puzzle. One, Metadisk is kind of your decentralized Dropbox-like application where you drag and drop and it's all encrypted and secure. And then DriveShare is the portion where actually the file chunks land or actually stored. So these two kind of fit together. Now the storage is not a particular software application itself, it's the platform that this is built on. So Metadisk and DriveShare are both applications within the storage ecosystem within the storage brand. So I don't think there will ever be a particular maybe storage application. There will be Metadisk, there will be DriveShare, there will be other variations of these, there will be other applications. But again, storage is the base layer of the platform, and then Metadisk is where people go to store the files, and DriveShare is where people receive those bits and host them. All right, what's next? Yeah, so someone gave a pretty good generalization of that. So yeah, you can perhaps think of Metadisk like a decentralized BitTorrent tracker. So instead of going to a centralized network or a centralized tracker, let's say. So you have BitTorrent, which is a decentralized network, works great, but then you have these decentral structures, these trackers like the Pirate Bay or all these other portions that can get shut down. Now the difference between a tracker and essentially finding information on the storage network is that we use blockchain and blockchain technology on the back end to store that metadata. So it doesn't matter what website or whatnot gets shut down, no matter. Essentially, we can retrieve that information to the blockchain. So we can have a particular portion that you use to find and get files. It falls off the server rack. It gets shut down. It doesn't matter. 5 seconds later, you could start it on the other side of the world, retrieve that information from the blockchain, and distribute it. So we see that as just kind of a better option, and it makes the network a lot more robust and a lot more resistance to censorship and all these other things that we necessarily don't like in our network. So do you think applications for web hosting or DNS could be built on top of the storage network? So there's essentially web hosting, yes. So one of the first things we want to do is essentially have storage be used, or Meta specifically be used, as almost a decentralized CDN. So one of the things we can handle really well is essentially static content. So videos, movies, pictures, all these kind of things that we can essentially push out through the network. And so essentially people would use a Metadisk node. So Metadisk nodes can serve both as a portion that you can store your files on, but they also serve as these kind of cool relays for the network. So for the Bitcoin applications and whatnot, you have to like download the Bitcoin Core client and you have to get all this stuff working. For us, we don't necessarily like that. Our full nodes are metadisk nodes. So essentially, you can connect to the storage network through just like an API. You don't even have to install anything or run any kind of special node. You essentially can just connect through any one of the metadisk nodes, their API, and then you can store files on there and retrieve files and whatnot. So we think this is a real good way to handle that. So essentially, you can start having applications that use storage network as a CDN. So you request a particular resource, that resource gets particularly popular, and essentially we can spread that resource on a ton of storage or metadisk nodes, and therefore you can get it really, really, really quickly and really, really fast, and you can't censor or essentially modify or do anything with that file. So we see it as a real good CDN or content distribution network. And then starting to think in the future, well, these metadisk nodes are essentially web applications. So we can also think of in terms of sandboxing things and start serving the websites themselves from metadisk. So it's really cool. DNS, that's probably a separate thing. I've always thought Namecoin was pretty cool on um, that aspect. So we'll see where something like Namecoin goes, but I don't think we'll be touching the DNS portion. That's kind of separate from data storage. Um, so yeah, you've heard a lot of complaints probably about Namecoin. I think it was a good start. It's a good technology, but it still has a way to go. The main problem with Namecoin is that you have this great decentralized system, and you want to host your decentralized domains on it. So storage.bit or whatever the TLD was for Namecoin. Now the problem is that getting that to the users. So I have this Namecoin domain that I want to distribute, and I want people to use. Well, by default, that's not enabled. And essentially, to get into this network, you have to download like some special software. And even in the beginning of Namecoin, like the software was like really complicated to install. And I think it was only till recently they had like a Chrome extension that you could get. So you're already excluding like 99% of people who are just not going to be able to um, essentially get the software installed and manage it and whatnot, and then even know what it is. So there was a problem getting that to the users. Essentially, if you want decentralized DNS, you have to get two people to accept it. You have to get the actual backbone provider. So you can say, hey, instead of taking your propagation time taking 24 or 48 hours, you can use a blockchain. It can take 10 minutes and be way more secure and all this fun stuff. And the other way to do it is get the browsers to support it. So get Chrome, get Firefox, get all the major browsers to support that system. But that's a very, very hard sell. That's a very, very hard sell. So where that goes, I don't know. Will there be another system? BitShares DNS is a good one. So I know the BitShares team and so that I did them. It's like if you want to get decentralized DNS into mainstream, you have to go for the backbone providers or the browsers. The users themselves, we're lazy. We're not going to go find something and install it and configure it. No, we just want it to work. So I hope that goes somewhere. It'd be particularly useful to us, but we'll see. Let's see. Yeah, there's also some pretty cool applications that they've built on top of Namecoin. I think One Name was one, and I think some people are pointing to some other projects essentially in the space that are using Namecoin. So great idea. Hope it goes further, but I think it needs some work. It needs some work to particularly get out there. All right, so I think we're running low on questions here. If you guys have any more stuff that you want to ask me, looks like let's see, looks like we're playing around with the tip bot here. Let me see if I can get the tip bot to work on my tip. Let's see. Playing around with a tip bot. I haven't played with this much. Oh, so what's the timeline on the Storj network? How many features are you planning on having in the protocol? So essentially, Metadisk, we're getting about there where we can start to put this out into production. So the things that we have to transfer is we have to kind of push out the drive data point that we've been using. And the other portion is that essentially we need to do a bit of a cleanup of the interface. So essentially, once we do that, we can push out the Metadisk network. And then for the drive share stuff, actually very, very soon. So I won't put out any particular dates on that. But like I said, we have some prototype farming software, and then we're working on a dashboard so that we can see all that information. So when that comes out, it's going to get blasted out on the email list. So kind of two ways of doing this, and I want to get some user feedback on my ideas. So share processing power over storage. Not in this particular application, but we are working with people to see if how we can do that. So I want to get some feedback from you guys directly on sort of my plans or my thoughts in terms of distributing our prototype software. So my thoughts were that we want to scale slowly. So we want to detect problems early and often, fix them before we roll it out to the next batch of people. So we don't roll it out to a ton of people and then you're like, oh, this doesn't work, and then we have to deal with a million people at once. No, we started with a small number of people, 10, 100, then 1,000, then 10,000, just scale up from there. So my main idea was that you'd essentially have the crowd sale participants go first. So we have about 1,500 people signed up for that participate in the crowd sale. So obviously they're going to get first access. So my thoughts were that we essentially have a cap. So if you have 10,000 Storj coin in an address and you participate in the crowd sale, so you'd be using that crowd sale address. You can enter that address and you can start to essentially participate in early farming. Now, the earliest farming, the early software that we're going to release, there's going to be no reward. We just want to test it out. We want to see the redundancy. We want to see the latency. We want to get statistics back from that. And then we can start adding on rewards and all this other stuff to it. So that was my initial thought, that you have 10,000 Storj coins, you participate in the crowd sale, then you can farm in the early network in a test network, which will start out as unrewarded and will move to rewarded. And that, based on the asset distribution on BlockScan, that's about 500 people. You just go down the list that have at least 10,000 Storj coins. Then we look to probably open it up to the rest of the crowd sale participants. So that's about 1,500 people. And then as a next step of that, we'd open up to regular people. But the catch is that they also have to have 10,000 Storj coins in their address before they can start mining. So we want to essentially encourage the holders to participate in the network and use the network. So I think that's yes. Huddle. We want all the huddles to participate in the network before we start opening it up. So that was kind of my 3-step plan. So A, crowd sale participants with 10,000 storage coins. After that, we open it up to all crowd sale participants. 3, anyone that has an address balance of over 10,000 storage coins. So they actually have some storage coins. They participate in the network. They're a holder. Then they can participate in this network. And like I said, it's going to start out as no rewards. So we just want to get a baseline, how this thing works, latency and all those things, and get some good statistics from that. And essentially what we're building out right now is a leaderboard. So you're going to see all the people participating in the network. You're going to see their address, the amount of files they're holding or the space they're holding, some rough idea of where they're at, whether they're in the United States or China, or Europe, South America, Africa, it doesn't matter. Then we're going to have things like the number of challenges they completed, how long they've been up, the percentage of the time that they've been up. So that's kind of like how our leaderboard's going to go. So all that stuff will be public. Everyone will be able to look on their score versus the entire network. So that's the thing that we want to push out first. So I want to get some feedback on that. What do you guys think of the plan? Like a 3-step plan, starting with unrewarded mining and then moving to rewarded mining. I just wanted to get some feedback on that. So let's see. Exactly. So that was our thought as well. So Viva says, it sounds good to me because it makes sure no one's incentivized to cheat the network before it has a chance to grow and be tested and upgraded. So essentially, yeah, that's our thoughts as well. So let's see. What else is on here? I want to try out the tip bot. Let's see. Tip. FTX. Looks like it's case sensitive one. Oh, it didn't work. Oh, I'm under this different username, so that would make it break. Never mind. Let's see. Fixes. When uploading a file, how does Storj decide which host will host the file? So the Storj network is fairly neutral. Essentially, again, it goes back to what I was saying before, that the user or the application gets to decide which host it will use. So one of the things you could do is essentially use providers, so public providers, to host a redundant part of your file. So you don't want to be entirely reliant on them, but you could have a Dropbox-like provider that's essentially accepting chunks. You know this is a person, the physical location, and trying to cheat anyone, and so you can host one of your chunks on that portion, and you know that person's reputable, you know they're great, and so you go with them. And the other 2 portions you can distribute, throughout the network with anybody. So essentially, again, you get to choose where those files go. The application gets to choose where to pull that from. So you're going to be going via a variety of sources. So you're going to look at kind of a public review listing, public leaderboard to say, hey, this guy has been storing files really great. He's been online, great. He has great reputation, all this kind of stuff. And then you might have, your friend down the street that's also participating in the Storj network. So you might want to select him to store your files over there because you kind of know him. So we want to give users that choice. We want to give them full control. We don't want to automatically to say, your file goes over here or your file goes over there. We want to give the user a choice. So let's see. If 1,000 people upload the same movie and put it as public, will only 3 copies be stored, and how many. So one of the cool things about our network, so we're rewarding for two things. We're rewarding for bandwidth and rewarding for physically storing the file. So if you have essentially 10,000 people put up the same file, well, the nodes that are moving that information around are getting paid on the transfer too. So essentially no one really has to pay for physically storing that file because the nodes themselves are incentivized enough to keep that file and transfer it to other people. In terms of that, there will be many copies on the network, not just three. There's going to be as many copies as it makes sense for nodes to have those copies on file to distribute to people. So more info on getting Storj coins. So the main exchange right now is Poloniex. So you can, that's where most of the volume is on for Storj coin. So you're welcome to go on there and grab some Storj coin if you don't have any, if you didn't grab any in a particular concept. Let's see. All right. So I think we're just about done with questions. So keep it. Try not to push too hard into the hour. So we can start to slow down here. I think we get some good updates on what was going on. So again, Metadisk, pretty close to pushing that out into production. You can try it out at the link that I gave in the chat, node1.metadisk.org. Just some bug fixes and whatnot that we need to hit. If you want to try the demo node, it's a little buggy. It's node3.metadisk.org. DriveShare, we have a prototype farmer, and we're working on some dashboard software to be able to see what's going on in the network. And then we'll be putting that out to early crowd sale participants. We'll be putting that out to early crowd sale participants on the terms that I discussed before. So we'll be sending out emails and information about that as well. And let's see, what else? And then, yeah, that's it. So we'll do another Hangout at some point that will actually be demoing off some of the software. So let's see. Let's grab one or two more questions, and then we'll bring this to a close. So what happens if people set up nodes in places they're not supposed to? Work, college campuses, private companies. So we're designing the software to essentially fly under the radar. So all the things are encrypted, and we actually are looking at it streaming to essentially you can broadcast the network at large, or you can broadcast to essentially Metadisk nodes. So the cool thing about that is that you can essentially broadcast or communicate encrypted over port 80 or 81. And so to anyone else, it looks like regular web traffic. It does not look like it is you're using Storj or using DriveShare or you're using Metadisk. So as long as you dial down your bandwidth parameters, it's going to look like regular traffic. So I think that might essentially solve a lot of problems on that end. Because as we start to build out this network, I don't think the ISPs and some of these people will really like us as we start to suck down their bandwidth. So we want to build it so that it's built to run on the radar, under the radar, so it can't be censored or stopped. Let's see. Oh, ETA on the Storj white paper. So we have a kind of draft copy that's sitting on our GitHub repository that's been sitting out there for a while. So the Metadisk white paper is out. The Storj white paper is kind of in flux. The thing is that we have a lot of the portions built out, but essentially we have 3 different algorithms that we're kind of deciding towards for doing the file verifications. And they're all kind of valid in their own right. So the question is like, which one do we do? Do we do all of them? So one was essentially a hash challenge algorithm. that I was developing. That essentially you take the file and you pre-generate all these challenges that only you know, and then you issue them to the farmer, and the farmer gives you back a correct response. And you say, okay, you have my file. And then Vitalik from Ethereum came in, and he gave me some good ideas on that. And so his implementation made heavy use of essentially Merkle tree. So taking the data, flattening it out, and building it up into this big Merkle tree, and then doing a Merkle proof of that data to prove that you store that particular chunk of that file. And then the third portion is something our developer William pointed out to me in terms of doing another proof of retrievability. So he has a third algorithm that he's actually implemented as part of our prototype drive share farming software. So that's kind of the holdup. It's like we have the other parts built out, but that like core algorithm, we have like 3 different ones that we could use, and it's like which ones is the best one, which one's the most efficient one. So yeah, we can throw a white paper, we can throw out this information, but it's really, as a scientist, someone's come from the academic background, we want data on it. We want to actually physically see, does this work under a live network? And that makes, if you ever built, done a research paper, that's what makes a good paper. So that's why we're kind of not pushing that too hard, because we want to put out the prototype network first. We actually want to try these algorithms in a live environment, and then we can get data back. And so we can actually prove, we can say, this algorithm, not only we think this algorithm works, but here's the data to support that algorithm works. And so that's what we really want to push, instead of just putting out, if you want to take a look at the white paper, it's in the GitHub repository, GitHub/Storj. You can take a look at that right now, and you can take a look at our draft. But really, before I want to put that out, I want data. I want real data. I want to say, this works. Here it is. I'm showing you. This is not just an idea. So that's what we're pushing towards, and we're getting that out fairly soon. So we'll be able to finish off that nice last portion. Let's see. Okay, I'll answer essentially, I guess, like 2 more questions, and then we'll wrap it up. So, will there be possibility to run the private storage network within a closed network? So, yes, that's actually one of the things that we really want to push people to use Storj for. If you have a particular company or whatnot that you want essentially a secure environment, you can run storage within your own environment, get that privacy, that security, that encryption and whatnot, and essentially just auditing yourself, or you don't even have to do auditing. So it becomes an encryption layer that people can use. So like Utropic said, you lose the benefit of the larger network, but you can essentially go back and forth. So think of it this way: you have storage running in your dorm room. You have a bunch of hard drives set up. They're farming. You're storing your photos and whatnot on it, and then you want to essentially distribute some of the stuff out. So you might have some other storage farming software running at your friend's house, and then your parents' house or whatnot. And then essentially you can distribute your own files on these other nodes on the network that you control. So you can run it in kind of your own environment and use the tools and the software like that. So you get that privacy, you get that encryption, that security that comes with the network. And so they pasted up the white paper, so you can take an early look at the white paper draft that's on the chat, and then you can look at the other algorithm that we're currently using for proof of storage, proof of retrievability. So you can take a look at those if you're more technical minded. All right, I think I'm going to start drawing this to a close. It's been fun chatting with you guys, answering your questions. You give me a little update. So the next one we're going to do is a little bit more fun in terms of getting to software demos. But all All right, I'm going to let me check some other places here. So yep, that's about it. So I'm gonna stay around the IRC chat a little bit more. But thanks for coming, and if you're coming on later on to watch this, thanks for watching. So see you guys later.